What's up, guys? John again, back after a while. I am going to be making a video today regarding wireless transmission in Minecraft Bedrock. So I'll try to keep it quick, but you know how that goes. So I figured I'll get the important stuff out of the way first, and then we can look into some of the things that we have lying around. So just to say right off the bat, I am going to be leaving a world download in the description in case anybody wants to see any of this stuff up close to learn how it was made or whatever. First of all, this video is going to be covering a new type of wireless transmission or a new method. So for those of you that are familiar with wireless transmission, it is still in the game. You can still use wireless transmitters and receivers. For those of you that do not know what wireless transmission is, it is a simple way to send a redstone signal wirelessly without having to run any redstone lines, whatever, to connect something. And of course, it's only going to work if the two areas where the transmitter and receiver are loaded. But uh, you know, that's it in a nutshell. So that blue thing here, this is a wireless receiver. Just to show a simple type of transmitter, you can power and depower a piston. So previously, whenever I went through with the wireless redstone stuff, the only method that I knew of to transmit a signal at the time was with a piston. I did test a lot of different things, nothing else seemed to transmit, but that is going to be the heart of the video today, is a new style of transmission. So uh, I had a question in the video regarding the wireless stuff, asking if it still worked. That made me want to kind of research if anybody else had done anything similar. And I did find a few YouTubers that were using different methods to transmit. So the way that I build receivers, which I will give a tutorial on this in a minute, the way that I build receivers, they have always been 1 bit per tick. My goal is always to send as much information as fast as possible. For that, you need a very high clarity transmitter and receiver, something that has little error. So that's what I've always been geared towards. But I noticed that some of the other guys were using a dispenser and water bucket to transmit a signal. So that was a bit curious to me because I had only known of pistons, but here you go, dispenser and water bucket. So I wanted to figure out exactly what the mechanic is that is causing a dispenser and water bucket to transmit a signal. So I realized it has nothing to do with dispensing water. It has more to do with having some type of redstone component next to a block of water. So in this case, we have an empty dropper, just powering it and depowering it. And you can see that we are getting a pretty clunky double pulse there. So not the greatest form of transmission because you're going to have trouble getting clean data out of that. So to go through and kind of show some other things, and I guess I'll say somehow, in my opinion, somehow this ability to transmit is tied into having a water update and a redstone update at the same time. But more than that, I think the redstone updates are tied to the water updates and they kind of force the water to update. So in this case, you can see that we have a repeater that is waterlogged in flowing water. And if you check the receiver back there, you can see that we are sending a signal. But if you look at what the repeater is doing to the water, it's like whenever the repeater gets powered, it's forcing the water to re-update. So you can actually interrupt the water flowing if you do it fast enough. So very interesting. Don't know exactly what the underlying mechanic is, but that's what it does. So here we have a waterlogged string just being viewed by an observer, and that will transmit a signal. Here, pressure plate simply next to water. So I'm guessing what's happening is with a change in the pressure plate, of course the pressure plate is outputting a redstone signal, but somehow whenever you step on it, that is also causing the water to become re-updated. So you can see that that is going to transmit. All of these components, when they are waterlogged with an adjacent water block, they will transmit. And what I mean by an adjacent water block, so in this case, we have a waterlogged repeater. So having a waterlogged repeater in and of itself is not going to transmit, but if we have some type of water next to it, either flowing water or a water block, then it will transmit. So I did go through, test a lot of these things for their ability to transmit, and I found the very easy method of putting a torch above water is also the best form of transmission. So with a torch, you have a pretty high clarity. It allows you to one tick it to get a one tick out on the output. So just to say, I think that this is related to the water updates and the redstone updates happening at the same time. And one thing that I want to show that kind of affirms that is going to be the rate at which it transmits through lava. So we can transmit through water. You can see that the receiver is going to pick that up very quickly. But to transmit through lava, it does transmit, it just takes quite a bit of delay. So, you know, water flows very quickly, lava flows very slowly. It only makes sense that if this will transmit at a fast rate, then this will transmit at a slower rate. So I did go through and test this in the nether with lava because it flows faster there, and it does transmit faster in the nether. So let's get into building a wireless receiver, and then we can get into some of the other things. So wireless receiver is a very easy concept. We are basically forming a burnout, and that burnout is able to pick up whatever is happening in the wireless environment. So the way that I build these, I always start off in a very specific manner. So we have to determine, because this is going to be made with two torches, we have to determine which side is going to be the output side. So you don't have to face any particular direction. You can make them whatever direction you'd like. But the way that I make them, start off with a torch, a block, and then dust in that order. Next, add a torch on the opposite side with a block on top. So if you see this state, we're going to see one of two different states here. If you see the state where one torch is on, that is going to be our output side, right? So if I make it differently from the opposite side, if we put our torch there first, and then a torch on the side with a block on top. So now we are in the second state, which is both torches are off. So to determine which side is going to be the output, you can just plop down a repeater or something and that will trigger the torch. So the torch that blinks is going to be the output side. And again, it doesn't matter what direction you build these. Just keep in mind that if you build them in different chunks, then they will probably have a different output location. So, you know, that's why I'm teaching you how to build them and determine the proper output side right now, because you're going to have to build them like this with in each chunk that you build them. So that is going to be our output side right here. So I'll just plop down a block there. So next, to complete the receiver on the side that is not the output side, put down a 2-tick repeater there. So that's going to come out into dust and a block. So pointing into the block, put down a comparator. Coming off the dust, put a comparator, and then 2 dust on the front. So you're going to need a target block in front of the output torch. On top of the block here, add a torch there with a block on top and a torch on the front. So next, above the comparators, put down 2 blocks with dust there, with a torch on the side there. And then finally, a sticky piston in front of that torch and a sticky piston on the target block. So once you get it made, it doesn't matter what it's doing, it's automatically going to refresh itself. And then we can just plop down a repeater for our output. So very simple to make. Just keep in mind that whenever you go into different chunks, you're going to have to rebuild it by hand. You can't really determine like, okay, this one is pointing this direction, so it has to point that direction, whatever. because that always changes per chunk. So very simple transmitter. Of course, we can just put a torch above water here and use that to transmit. So because this is going to be in a world download, I'm just going to get rid of all this junk. Try not to leave too much junk lying around. If you want to see a receiver up close, I have receivers everywhere. So, all right, let's get into some of the types of transmission that you can do. So previously in my other wireless redstone videos, I did show types of transmitters like this. So this is going to be a transmitter with a 7-bit address with 8 bits on the output. So just to show that transmitting through the torches has much greater bandwidth than my previous design with the pistons. You don't have to worry about having any type of special configuration. As far as the transmitter goes, we are using pistons here as AND gates. So whenever we make a selection in the front, that's going to turn that torch off. Then whenever the torch coming off the top there is going to power off, that's going to allow the torch on the bottom to turn on. So you can see that the transmitter is really just a string of observers that turns the torch off one at a time. And on the bottom, the actual means of transmission is going to be the torches turning on down here. Okay. So from here, you can see that if we want to transmit to the different addresses, so this is the address for that one. So if we want to transmit to the back one there, you just turn that bit on, and then we can transmit something back there. So this is basically the same style of transmitters and receivers that I've always used, except it has greater bandwidth, so you can send more data. But just to show how much accuracy is involved and how simple it is to transmit now, you could play around with this if you wanted to. This is a 24-bit receiver. So, but like I was saying, very simple to make. You just have torches above water, and in fact, it's much easier to make a wireless transmitter now than it is to make a wired receiver. I mean, a wired transmitter. So some of the other things that you can do with this, you can transmit analog signals using the pulsing method. So here we are using a pulsing transmitter as well as a pulse width receiver. So if I wanted to send 14, then you could send the analog signal 14. If we want to send 2, then you can send 2. So the method that this is using to transmit, so we are sending a single tick pulse from the observer. So depending on which observer you select, it's going to have a greater or lesser signal strength here. And that single pulse of signal strength is going to come into this 3 comparator clock. So as the signal cycles around in the clock, we are going to subtract 1 from it each cycle, which means that, of course, if we trigger 14, then we are going to have 14 cycles here in the clock, right? So each pulse is going to come out to this type of transmitter, and what this does, this is going to blink because we have a 3 clock. We are going to blink these torches in a sequence. So first is going to be this torch. 1 tick later, we're going to blink that torch. Then 1 tick later, we're going to blink that torch. Then after that, we are going to start back at the front, right? So we are blinking these torches in a 1 tick, 1 tick sequence, I guess. I don't know how you'd say it, whatever, but you can see what it does. So whenever you blink the torches that quickly, that is actually sending, if we look at the display back here, you can see that we are sending a full unbroken signal to the wireless environment, right? So that is how we are outputting an analog signal here, is by turning that torch on for a certain amount of time. Okay. So you could probably also do that in a different way. So if I say, I don't know what this is going to be, but this is going to be an analog number of some duration, you know? Okay, so that is equal to what, 6? But I'm going to turn these off because if we forget what the proper address is, then we are going to be in trouble. So anyway, you can transmit analog signals wirelessly as well as with the data stuff. So let's get into a more complex discussion, and this is probably going to be the boring part, but we always have a problem with noise in the wireless environment. So unfortunately, we can't do the same thing that we can with, just say, the Wi-Fi in your house, or with anything else that sends a wireless signal, because that has the ability to try to send data. Then obviously you're gonna have some type of receiver that can check the data and see if it's correct or not, and then tell it to resend the data if need be. So even in the real world, even if you have interruptions with data, really that's only going to occur on, if they are like really close to the same frequency. Otherwise, antennas will naturally snuff out any signal that's trying to interfere. But in this case, we don't really have that option. Anything you can see, like anything that's even going to be a piston going off somewhere, if you have any type of farm running, that's going to produce noise. Of course, if you have a dispenser or something next to water, that is going to produce noise. So everything in the wireless environment is going to produce some type of noise. And the problem with that is that any of these types of transmission will not be able to operate if there is any noise in the background. So obviously you can't send an analog signal because that's just going crazy. Likewise, you can't transmit anything like this because these all require there to be zero noise in the environment to be able to receive a signal. So is there going to be a way in Minecraft that we can transmit with noise or transmit through noise? So let me show you something that I came up with. This is kind of a proof of concept, but I think if we could develop things like this, maybe on the same line, then we can have much better forms of transmission. So to start this up, you have to go around and start every clock. And this method of transmission is relying on synchronized clocks. So I'm going to show you how to start everything up. So we're going to have one clock on the receiver and one clock on each transmitter. All three of these are transmitters, by the way. So the way that you synchronize the clocks, we're just going to select a bit here and see where it lands. So we can alter where the bit is going to be displayed on the output by adding repeaters here. So I'm just going to go through and synchronize all of these transmitters first, right? So, and it does take a while, you'll just have to bear with me. So that's the last one, so we only need one there. And that should be displayed on the first bit. Okay. And finally, we have a 1 in 4 chance of hitting the right output here, so nope, that needs 3 repeaters. Okay. All right, so everything is synced up. So let me explain to you what this system is and how it operates. So let's just go ahead and select the first one there. So this is kind of like the version 2 that was the original version of receiver that I made. So we have synchronized clocks. We have, as far as the transmitter is concerned, we have a 4 clock, and that is going to be sending a signal to this torch whenever we have it selected. And you can see that the torch is going to blink once every 4 ticks. So each one that we select is just going to deviate from the original signal by 1 tick. So you can see how that is transmitting there. Each one is blinking in a sequence. and that is what determines the output location of all these bits. Okay. So on the receiver, we also have a clock that is going to be synchronized with the output. So just to show that you can actually change the output by changing the timing here. We have a wireless receiver that is picking up any signal being transmitted by a blinking torch, and that is going into this goofy looking machine. So I tried to include the C lamps to cut back on the redstone light updates. So that's why you see all the sea lanterns, whatever there. So let's get into explaining what this is and how it operates, and we can show you what it's good for. So here, the old model, you can see we have the wireless receiver. That's going to be coming out into a chain of repeaters here. Basically, whenever we get to the end of the repeater chain, we're going to loop back around and come into this one. When that gets to the end, it's going to come back to this one, and on all the way down the chain. So each one of these first repeaters is going to output with a torch to a dust line on top. So if you can see what this is, we are forming a giant AND gate with each of these torches. So let me let you see how this operates. So because we are sending a recurring signal on the input, it happens in real time. It's going to give us one tick or one bit every 4 ticks, right? So we have our first bit there, and then every 4 ticks we are going to output a bit. So we're going to have another signal there, and then another signal, not there, but there, once every 4 ticks, and then there, and then finally there, right? So if we have a recurring signal over a certain amount of time, then one of 4 ticks over time we are going to be outputting a signal, right? So the way that this is operating is, like in that case, we have a giant chain of repeaters. That's kind of the same thing here. But what that means is that whenever that signal recurs once every 4 ticks, that means that whenever it gets to this repeater here on the end, it's going to be there at the same time as it's going to be there. At the same time, it's going to be there. Oops, shouldn't have broken that. At the same time, it's going to be there, and on down the line, all at the exact same time, and that is what is allowing us to have an output here. So whenever we have a recurring pattern for a certain duration of ticks, we form an AND gate, right? So it's an AND gate over time, which means that for it to actually display an output, it has to happen for a certain amount of time. And in this case, I believe that is 40 ticks. So whenever we output a single pulse every 4 ticks for the total span of 40 ticks, then we will display an output. So that's why it takes so long for the signal to be reflected on the receiver, right? But because it is a recurring signal, it must be a recurring signal, then that means that any little bit of information that we get in the wireless environment, such as a simple piston being pulsed on and off or water being dispensed, then that is not going to have any effect, because for an output to be displayed, we have to have a recurring signal for this many bits, which means that if I have a piston firing here, or a dispenser firing here, or a piston firing here and here, then that's not going to show anything on the output, because it takes a very long recurring signal to be displayed, right? And it just so happens that with the 4 clock, that happens at a different rate than a trident killer. So we can run this thing even with a trident killer running in the background. So we have a lot of noise on the system just from the trident killer. That's what this is, right? So this is all the noise that you're seeing from the trident killer, and yet it is not going to display an output. So we can still transmit and receive data even with a trident killer running. So one of the other interesting aspects of this is its ability to send and receive a signal from multiple locations. So in this case, we have two transmitters here. They are both sending a bit from different locations to a centralized receiver. So we can transmit signals in real time from multiple transmitters to a single receiver, which is something that is pretty unfounded, at least in Redstone tech. So with any other type of transmitter, of course, you can, if you have a very clean wireless environment, you can transmit from one transmitter to multiple receivers at the same time. If you wanted to, you could have each receiver pick out a piece of the data that's transmitted to display. So, you can output some data at one receiver, output a different set of data at the other receiver at the same time. That's not a big deal. But in this case, we have multiple transmitters, and they are all transmitting to a central receiver at the exact same time. And we also have noise, like a trident killer, or even a trident killer plus a piston. We also have noise going off in the background. So I find this thing to be pretty fascinating, even if it is a little bit on the laggy side. But it is going to be in the world download if anybody wants to play with it. I think that it could use this type of transmission, even if we can get rid of the synchronized clocks. I think that would be great. But I think this type of transmission really does have some great potential to be able to transmit from multiple transmitters to a centralized receiver. So I have gone through in a different world and tried to do other things like take each of these outputs off, uh, you know, take these off and then use that to send data, but you would actually have to build a pretty complicated system to, send more than 4 bits. So anyway, I'm going to shut all this stuff down, and I guess that is it for the video. So I guess I will see y'all in the next video.